Sure.
All right, so Matt, I'm going to start with a quick introduction about myself, and then I'll let the team introduce themselves as well. My name is Venus, and I am coaching team 45592, Vice Marble Engineers. And this year's first LEGO League theme is Cargo Connect. So they're working on a project which kind of helps with packaging, delivery, or transportation. So either of the two. So they are specifically focusing on being eco-friendly, making Earth a better place in terms of saving the renewable resources that we have in their project. And I will not steal their thunder. I'll let them talk about their project. And we really appreciate your time.
Yeah, absolutely.
All right. So Pawan, do you want to go ahead and quickly give us your introduction?
Hi, I'm one of Wise Marvel Engineers. Is that all I'm supposed to say?
That's fine. All right, next.
I'm Inyan. I'm in Wise Marvel Engineers. I study in Capel. I go to Capel Middle School North. Oh, I'm in 6th grade, by the way.
Nice to meet you.
Hi, I'm Elise. I'm in Wise Marble Engineers. I'm 13.
I'm Nikita. I'm 13. I'm in Wise Marble Engineers and I go to Green Hill School.
Hi, I'm Tanvi. I'm part of Wise Marble Engineers and I'm in 6th grade.
Hi, I'm Devarikia. I'm part of Wise Marvel Engineers and I'm in 6th grade.
All right, Shrihan.
Hi, my name is Shrihan. I'm in 6th grade and I'm part of Wise Marvel Engineers.
All right, we're also joined with my co-coach, Kala. Kala,
hi, Venus.
I
can hear you.
I'll give you a quick minute to introduce yourself to Matt as well.
Sure, thank you. Hi, Matt. Nice to meet you. So Venus and I have been working with this team for a couple of years now, and this is an exciting team. And every year we have been coming up with new challenges, solutions, and everything is fantastic. Glad to have you with us today.
Absolutely. Nice to meet you all as well.
Thank you.
All right, thank you guys. So Matt, if you can just give them a quick introduction about yourself and a brief about Micropsi, that will help them. They have seen you quite a few times in your video in action, but I think knowing that firsthand will give a good information to them.
Sure. And Venus, I guess real quick too, I probably should have reached out right before, but what all do you want this to kind of look like? Because I have, I don't have the physical robot right now, but I have a video of me demonstrating it that I think will be at least be comparable. So I'll play that for sure at some point.
No, that's absolutely fine. That's
okay.
absolutely fine.
Do we want a fair amount like questions and answers at all, or was it
So yes,
I have like a presentation I can use, but it's kind of like just copied from like a sales presentation essentially. So I think it's worth sharing some of that, but I also want to make sure, we get everything out of it that you all want to.
That would be a great opportunity as well. And what I would do is, I know some of these team members, they are exclusively working on the deck. What I will do, I know that's work in progress, but Tanvi, maybe I can put you on spot to give us a quick walkthrough of the deck. So that'll give Matt an idea. And Matt, what we're looking for, adding some more pictures, descriptions to, what they have kind of come up with the outline in their PowerPoint. So that way you'll have more information of what things, and if you think there's something else that you can provide that they could substantiate their idea, and picture speaks louder than words. So I'm a big fan of that. So that way they can include that as well.
Absolutely. Okay.
All right. Tanvi, do you want to go ahead and share the deck and just give a quick walkthrough? We understand that's work in progress, but I think that'll give Matt a really good idea about the progress you all have made so far.
So this is our innovation project by us. Our main problem is trying to optimize the usage of cardboard and minimize the usage of cardboard used into box products and other products. And then our second problem is order consolidation, which this means is whenever you're ordering something, at one part of the day, let's say at 12 p.m., you ordered a good, but let's say your neighbor ordered the same thing at 3 p.m. But then you both get that good, but delivered at different times, which can which means more trips to deliver goods. So we're trying to consolidate 2 orders into 1 trip, so we don't have to waste the number of trips that we can take to deliver goods in the same proximities.
No, that makes sense. I know, yeah, Vina shared a little bit of that. That's awesome.
And this was actually our second idea, delivery time able to be reduced. We were planning to use a technology called Neo4j to do this. And we actually, just like the Google form, we reached out with people via Google Forms, and we researched, we wanted to know more about how do companies like manage packaging goods. We figured out they use TMS, MRP, and ERP. These are just softwares that they use to package items and deliver them. And then for our solution, we're planning to use machine learning to scan products so they can decide the box that can be used and the dimensions of the box, and like a scanner. And along with AI and ML together, we can do that. We're also planning to use remote process automation that can help with the order consolidation. So these are industry experts. We are planning to meet with a couple industry
Matt, I stole your picture from LinkedIn.
This is basically what I was talking about, using AI machine learning and RPA, remote process automation. And we're planning to make a trifold for our project, which we're planning to use a trifold.
You make that one just kind of like a reference
Just
for
our like
something
layout so
look like.
far. This is just like our layout of the project.
So Tanvi, can you just go on to slide 11, just talk about your tagline?
Yeah, so our project is called Save Our Planet, and our slogan is one step at a time. We were planning to talk about our problem, our solution, our prototype. This is selling information is basically like how much will our prototype cost, more how we'll sell our prototype, or like that aspect of it. And then this part is just sharing our solution and talking with industry experts.
So Matt, they are required to have a little bit of an insight of, if you were to sell this product, how would the pricing be structured, just so they have some kind of a background on financing aspect. So if you can just give them a brief overview of how they should look at financing or the pricing of selling the product, because in this case it's going to be hardware and software, that will definitely help them as well.
Sure. So you're saying, like, referring to like to my product, like how the pricing would work with that.
Yes. And then they can draw parallels, and then they can come up with their own logic of whatever price they situate and why they are stating what they're stating.
Okay, sure. So yeah, our system is just the software element. It does come with a couple pieces of hardware. So for our software, for a camera that you have to use to be able to guide the robot where it goes, and then a specific sensor that has to be included. Our system is $25,000. It's a one-time purchase most of the time. We do have a different model I can tell you as well, but it's $25,000 for our system. What you would need to make it truly work, because again, we're just talking about software really, you would also need a robot and then some sort of gripper, so something that's going to grab it, or do whatever other action. You could do a suction cup gripper for boxes, for example, or a 2-finger gripper. The robot is going to vary on price a lot depending how big it is. I will say probably from like $25,000 to about $60,000 for what our system would typically be used for. So all in, our customers are usually spending probably $50,000 to $80,000 total on a solution. We do a subscription as well. Sounds like you all are at least, relatively familiar with AI and machine learning, and it requires a lot of server space, or server, efforts. So we can do a subscription model where essentially a customer could pay $1,000 a month to just keep renewing that. Because of where we're selling it to, like in industries, they typically prefer just to pay the one-time cost. So the $25,000 for our system, again, 60 to 80 for a full setup.
That helps.
Hopefully clear that up some. Cool.
And team, I want this to be an interactive section. So if you have questions, raise your hand so Matt can take answers in turns.
And if you want, I can jump to this PowerPoint and at least like have some background going on. So that
I think that would be helpful.
Let's do it.
Yeah.
All right, let me just open it up here real quick. And I meant to ask that and then introduce myself a little. So I will jump on that. My name is Matt, as you have heard probably, but I work for Micropsi. We're a German company. So I'm actually the only person in the US that is working for Micropsi right now. We're hiring a handful more, but I'm here in San Francisco. Our company's been around for about 7 years on the engineer side. Software engineers started developing it in 2014. And like I said, most everyone's based out of Berlin. We do have offices in Zurich, New York City, and then myself here in San Francisco. It sounds like you guys touch robots, so just a quick background that hopefully will help make the product make more sense. It sounds like you all have a pretty good gauge on it. But right now, when you're programming robots, you are teaching them XYZ coordinates. You're telling them geometrically exactly where to go. That's kind of the beauty of robots, is you teach them something, you program them in a way, and they do the exact same thing over and over and over extremely accurately. The problem is there are a lot of things out there. We use cables a lot as examples, but you could even use boxes. I don't know how many thousands of different shaped boxes and envelopes and whatever else there is. Because of that, it's hard to pre-program it. You really need to be able to look at it and say, okay, the robot needs to approach from here. Or if you have a large, long box, you want to make sure you find the center of gravity. You don't want to end up on the end and grab in the wrong place like you would maybe for a smaller, more dense box. So that's where our system comes in. I've talked a little bit about what it is. I think you can see my cursor, I believe, but this black box is what holds our software itself. It's connected to the outside world via just Ethernet cable. And then this is a universal robot. So it's one of the more popular robots out there. I don't know if you all have ever been able to get hands on a robot, but these are great ones to learn on because they're called collaborative robots. So humans can work right next to them. If you turn it on high speed, as high as you can, and you let it slam into you, it's going to hurt. It might leave a little bruise, but it won't kill you. So that's not true for some industrial robots. So these have become really, really popular. They're also not as fast, which is how they, are able to get away with that. And that means they're a little bit less expensive as well. This specific one is probably about $35,000 for the robot itself. I mentioned camera as well. That's the camera that comes with our system. It's pretty straightforward. And then a 2-finger gripper that's grabbing wine glasses in this case. I'm going to jump to kind of how it works, a pretty quick run through on it. Any questions though? I can stop here for a second.
Is it electrically powered or is it battery powered?
It is electrically powered. It's just a standard wall outlet. So, at a lot of manufacturing companies or, these distribution warehouses, they may have an option to, run a little extra power into an AC power, but we really are, extra voltage, we'll say. But for this, it's just a standard plug it into any wall outlet.
Does it require like a lot of electricity?
It's not too bad. I can probably help. I'll make a note and I can figure out exactly what kind of what it's pulling. I have it on I'll say that I've run it a lot in my office and even at home some, and I've never noticed it showing up on the electric bill. So I imagine it's pretty pretty minimal. So as far as like an environmental impact, I don't think it would be much, but I'm sure you can find that. For what it's worth, if you're making notes at all, the robot, it's a universal robot and it's a UR5E. E is in Edward. So you can look it up and find any sort of specs you'd like on there. So a little bit about how it works. Like I said, we're not selling the robot itself. We're just selling the software portion of it. So our system, you're gonna hook everything up, pretty straightforward. If you know how to use a screwdriver, you can do that. Takes about 5 minutes. And then the main step that makes our product different, when you're typically training a robot, you are, like I said, you're plugging in numbers, you're doing geometry, you're doing XYZ, you're saying, move X amount of millimeters to the right, X amount of millimeters down in Z, we would call that. And you're really putting in precise things. With ours, it's different. You're actually teaching it instead of programming it. And by teaching it, I mean, you're grabbing it by the wrist, you're pressing a button to say, start recording this, and I'm showing it what I want it to do. So in this case, my coworker there is grabbing it by the wrist, approaching the wine glass, and then just recording that over and over. And by using machine learning, it's imitation learning is what we're using. If you're familiar or if you're not familiar, imitation learning is essentially, we're photo matching. That camera is taking 40 frames per second, and every one of those frames is an individual picture. It's throwing that into an algorithm, and that's how it's doing that machine learning. So it knows, if we're going to that wine glass, it's on the left. We've taught it so many times, it says, okay, my next frame needs to look like this. The next frame needs to look like this. And it just keeps on getting closer until it finds that perfect spot. So that's what we do. We are teaching it. We're sending it to a cloud. That's where, the software takes over and crunches out a little node that you're going to put in a program. And then you're going to test it out. If it works great, perfect. You're done. You're good to go. However, let's say we're picking up these wine glasses and we realize, oh, I didn't realize that it could be upside down, or maybe this one's a little shorter than normal. You don't have to start over. You're just going to go back to the step 2 and show it what it struggled with, just like you would a human, really, where you're saying, okay, I taught you how to do this. I didn't think about this potential problem. Now, if the problem happens, you're going to do it this way. You're sending it back to the cloud, and then it's coming back again, kind of an iteration 2.0. And you're just going to keep building on that until you get something that you need to do. So if you were showing it boxes, maybe you show it 100 different boxes, or 10 different examples. And then all of a sudden, wow, Amazon's changed it up. They're using black boxes now. We've never shown it that. You could show it some black boxes. It doesn't start over. It just adds another layer on top of that, for example.
And Matt, what does MIRAI stand for?
So I don't know the exact backstory. There's some German engineers that I think it was almost an inside joke of some sort. I don't think it stood for anything, but there's some sort of weird like sci-fi German background about what it stood for.
Is that a name for the robot? I'm guessing.
That's what we call our software system. Yeah, Mirai. We say Mirai. And that's the name of our product.
Got it.
Yeah. Next, I just have a video. It's kind of funny because I'm sitting here talking to you, but I'll show a video of myself. It's a little bit, it wasn't necessarily made for this. I actually made it. My coworker was visiting from Germany and he wanted to film how I do a demo just to help out some of our other coworkers. If that's all right, it's about 3 minutes long, I believe, but it run through 3 different just demos. I think it probably might help show it. Is that worth it, Venus?
Yeah, absolutely.
Okay, and the sound will be on it, I believe. So I'll mute myself here.
All
right. All right. So goal here, pick up the M. So no matter where I place this, anywhere out here, system's gonna react, go where it wants to be, go down, pick it up, and hand it off to me. So our system just takes over for the first portion to make sure we're positioning it in the right place. So if it's sitting up like this, great. Even in real time, if we drop it, it goes to a different angle. Our system doesn't pause, it just reacts and says, okay, now I need to approach it a little bit differently at a different angle. So whether it's sitting upright, laying down, or even if we come in with a smaller part and say, now it's a smaller version, same idea. We've got to approach it a little bit differently. The image certainly looks different, but it still knows how to react. Wow. And last, even if we are laying down with a smaller one, so really our 4th different version, we can bounce that around in real time. It's going to adjust and get to the right point. That's the M.
That's impressive.
Now for beakers. So the way I've trained this one is to go after the first beaker, no matter which one it is. So let me go ahead and open up that program. And I'm just going to run the same program on a loop over and over, each time going to pick up one beaker. So it sees first one, doesn't matter what color it is, there's no certain orientation or anything going on there. Even if I switch it up, go to this side, it's going to go after the first one and grab it. You're seeing some positional change there. I'm not necessarily keeping it in the exact same place. So if I have it right here, and then once it starts, I'm going to change it to that angle a little bit. Even if I'm moving it and it overshoots it, it knows how to get back to the right spot, make sure it grabs that beaker right in the middle, goes for the next one. And again, we're not going 1, 2, 3, 4, 5, 6. We are just simply going to the first one. So even if I throw a beaker back in there, it sees, oh, look, there's a new one that's been loaded. Let's grab it. Even if I skip to the very last one, that's all that's left. It's going to go there, grab it, pick it up. Now we picked up all of them.
Wow.
So there's like one more part of this. What I think I'm going to do, just partly to respect y'all's time, I have a little extra. So if we need to go over, I'm okay with it. But for y'all's sake, I will send this PowerPoint because there's a few things after it that might be interesting. I'll send it to you, Venus, and feel free to distribute it however, there's no like rules on it. So feel free to send that to the students and anyone else that needs. You can also, all of the videos are embedded onto it. So I'll have to send it, just through like a file share. But if you want to take any of those videos, the files, you can also, use those or screenshots or whatever you want to do with those. Just let me know. Or you don't have to let me know. I will be very curious to see your guys' project as it grows, but yeah, in general, you can use that as you would like.
Sure.
I have a few. The other thing that was on this PowerPoint was more of like, what are we using it for in the real world? I don't have any like distribution centers per se. Actually, I tell you what, I'll hit one more point real fast, and then I'll kind of let you, we can go where we want to go from here. What kind of variances can we work with? Position, I showed that quite a bit of moving that M, for example, around, and it's in a different location each time. Same with you have like a product of some sort coming down a conveyor belt. No matter where it is, we can find it. Lighting is something that as you all kind of get more involved into this, you'll hear, if you haven't already, lighting for cameras and for measuring and for everything is extremely important. One cool thing about our system is it's not quite as important in that if you think about it, again, we're just comparing images. As long as we show different lighting situations, so maybe this distribution center, for example, has a ton of natural light. The daytime shift is going to look a lot different than the nighttime shift. As long as we show both of those to our system, it doesn't matter which one it is. So we can account for lighting changes. And then lastly, form. This might be the most important part for your project, to be honest, is you're never going to be able to reasonably show any camera, anything, every single box size, every single look of a box you've ever seen. There's going to have to generalize a little bit. So our system, if you show it, if I showed it 5 different boxes that were all, 6 inches different between each other, and then you pick, then you show it a box that's somewhere in that range, but it doesn't match up perfect, our system would adjust and generalize. Again, that's kind of the power of the machine learning side of it.
Nice.
And then the only thing I have left really on this was, again, some customer like real world applications. What I think I'll do is I'll just send you this and you all can certainly review them on your own time. And if you have any other additional questions on it, that's great.
Yeah.
So yeah, I hope that helps some. One thing too, I'll just say, just from my previous job a few years ago, I used to work at a company called Keyence. It's a Japanese automation company. They make some cameras that are also really cool that can actually do measurement, and they do them really, really fast. So I actually used to go to Amazon warehouse, a couple of Amazon distribution centers, and the way they would measure boxes, at least, was they would come down and they would use these vision systems that would take a picture and use lasers, and in like split seconds, milliseconds, they would be able to say this box is X dimension, XYZ dimensions, and know like everything about it. So that could be something that's at least worth looking at. It would just be measuring vision systems essentially.
What is the name of the company called?
The one I'm talking about, I'll put it in the chat here because it's a little spelled interesting. Keyence is one, and then Cognex is another good one. Laser measurement systems. If you look up that, then I think there's some pretty cool stuff out there where it's scanning essentially as it goes by. And that is what a lot of these distribution companies are using in some way, shape, or form.
I think we watched a video on Cognex, I think.
Yeah, I think we did.
It was
Nice.
about
Yeah, I mean, it's definitely a good one. And in some ways, I think actually the Amazon I used to go to used mostly Cognex. So yeah, it could totally be worth checking out. I have friends or old coworkers that are there. So if that is something you guys start going down, have Venus connect me again. And I'd be happy to see if we can find somebody that can share info on that if you guys start going down that track.
So Matt, just to elaborate on what you just said here, so that is making the determination of the dimension of the product to be packaged.
Well, to some degree, yes. And again, I wasn't really what I was ever working on there, so I don't want to like speak and speak falsely at all. But essentially, that is what it's doing. I mean, you can't see it. Let me see if I can just pull up a video or a picture really quick just from the web.
Because one of the things that they are expecting for the team to do is understand the concept of iterations. So version 1, you can focus on an X amount of scope, and then you can add additional scope to your project, right? So that way they're also instilling the concept of you don't start with a huge scope, you kind of piecemeal it. And I think this would be a good iteration for them to add, because as they go from one level to the other, the judges are expecting them to, what is it that you can add as the next layer? And I feel that, this is something potentially they could add as an iteration 2 as well. Iteration 1 is primarily focusing on scanning and making a determination using the machine learning and the deep learning that what is the optimal size of the box based on the image that they are seeing or the product that's there on to be packaged. And then, further on, they can be more accurate with the dimensions and add more algorithms to it.
Yeah, I mean, I think that's perfect. I mean, that's exactly what a lot of the big ones are already doing, and it's totally worth considering. Just to give you a very, very quick idea, this is that scanner, and I think it's a small part they're about to show you, but it'll give you at least a quick general idea of what I'm talking about. It's an LJ, so if you want to look it up, just look LJX. But you of course can't actually see that blue laser, but that's what's happening. And then as a part goes down, a conveyor belt, for example, it's scanning even these microchips. I mean, these very small parts, and it's giving a profile that's getting put out in like a CAD file, and it will make like a 3D image of it essentially. So all that's kind of happening in the background, but you could pre-program it and say, hey, if it's this height or this orientation, then we need this big of boxes. So anyway, a little bit of a side point, plug for my old company, I guess, but
that's awesome. Out there. That's awesome. So I know we're at the top of the hour. Team, I'll open this to your questions right now. So if you have any questions for Matt, please feel free to add or ask those questions. And as Matt mentioned, once I have access to the PowerPoint, I will share that to you so you can incorporate things in your PowerPoint and a deck for you to be more informative about your project. Any question, any going once, going twice, any questions on the table? All right, so Matt, you did a great job in explaining them. They got it.
Yeah,
Thanks so much.
Absolutely. No, thank you all. It's
thank you.
Thanks for having me, and good luck on the project. And Venus has my contact info. So genuinely, I've been in the automation world for about 7 or 8 years. So not forever, but for a little while. So if you have any other generic questions, don't hesitate to reach out.